Okay, good evening. Hopefully everything is set up audio-wise, and that the stream is working now. So another live stream, another session of working on the chess engine that we've been working on I think the last 5 or 6 sessions now. So I can give a quick update about some of the work that I've done in the meantime. The board representation is coming along pretty well. Oops, let me go ahead and share my screen. And it looks like I need to start Jupyter Notebook as well. Yeah, so last time I think that I had stopped at a point where we had a lot of the board representation figured out, but I hadn't quite figured out things like castling and en passant. And since then, I have completed sort of initial versions, we'll say, of both en passant and castling, so we can take a look at that. I've cleaned up the project a bit, so we have a separate directory for notebooks, and I currently am just working with one Jupyter notebook. They may have been kind of interesting to keep around to look at how the notes have progressed, but it's in version control, so if anyone is ever interested, we can go back. Hey, what's up, Alvaro? Good to see you again. I hope you're doing well. Hopefully, I can show some progress on the chess engine, and we'll actually get to some of the fun stuff relatively soon, I hope. Um, so everything is now importable from Wake as the project. I believe last time I did show that I've created a ASCII board representation mode to go along with the bitboards. But I think the last notes I was making here was to look at en passant. So you can see if we have a pawn on e4 in this case, and the black pawn is just moved to f4, or yeah, to f4. Okay, the next one it moves to f5, and then we can take en passant. So you can see that the piece map updates correctly at this point. Had some other notes there. You can look at the occupied squares. We also have in place promotion. So actually, I'm pretty sure if I run this notebook, we should actually just see that. So I'm going to go ahead and give that a shot. So we're making a bunch of moves here, playing a King's Gambit. And the way I'm handling promotion is just taking input from standard in right now. And you can type in the letter, or you can type in the name. And that's the other thing. I have FEN wired up now too. So we're actually getting FEN back. And I can review that. So we have a queen up here now. And it does remove the piece that's captured, the piece that promotes. We remove the pawn and we replace it in the piece map with whatever we put in there, so a queen or a minor piece. And then just to show that it is in fact treated like a queen, we can look at the white queen attacks bitboard, and we can see that we have queen attacks now from both the queen on d1 as well as the queen on e8 in this case. So that's pretty exciting in terms of board representation. These are old notebooks. So the project is a little bit of a mess code-wise. So things are looking a lot better in terms of like the actual working implementation of the board representation. But I'm definitely not 100% satisfied with the way that the project is laid out. So we have a bunch of redundant code right now in the position class, which kind of grew uncontrollably as I was working out the implementation details for en passant, castling, and promotion. But it actually contains a lot of piece motion code that it has already been created in the static bitboards that I created initially in the board class. Alvaro, no problem, man. I'm streaming a lot. Siddhant, good to see you again. Actually, a lot of the work the last couple of streams has happened like off stream, and then I just kind of ramble on stream and get stuck on problems. So it's probably better that people don't watch these streams. How's that for self-promotion? All right. So yeah, as I was saying, like this position class has grown quite a bit. We can take a look at some of the simpler things first that are new. So FEN generation was actually simpler than I thought it would be. It's pretty procedural, but we can take a look at it anyway. I mean, thanks. Um, and oh yeah, the time on the screen is not working. I'll set this off. So I plan on working for about 2 hours or so, give or take. And said, huh, yes, I did see your PR. I will get to managing any PRs that come in on the project after I sort of am happy with the V1, and some of the things about like the setup.py and things might change. So I will definitely keep it open. But thank you for submitting that. So Siddhant submitted actually the first PR, which was just to improve the README a little bit, I think, and do some basic setup. But thank you for doing that. All right, so this FEN, so the way that FENs work, apparently, this Forsyth-Edwards notation, the first thing that was really interesting is that it's actually pretty old. It's an old system from the 19th century, I guess. And then Stephen Edwards extended it for use by computers, which is obviously what we're doing. So here is the idea, and the other thing I can open is Lichess. Of course, anyone can challenge me to play, and we can play later, but I would also just like to keep open the analysis board. And Lichess will actually show you the FEN for the current position for any position, so it's kind of useful for when I was debugging. So the way that it works is you actually read the board from top to bottom from white's perspective on a standard 2D board like this. And so the back rank is, we can see the FEN here, rook, knight, bishop, queen, king, bishop, knight, rook in lowercase letters, and then a forward slash, and then P's for pawns, lowercase. And then so you can see what happens is basically the rows on the chessboard are delimited by these forward slashes, and black's pieces are represented by lowercase alpha, and the capitalized cars are white's pieces. And anywhere you see a numeric value like 8 in this case, that signals how many open squares there are as you're sort of scanning. If you're imagining sort of like bit scanning this board from A8 all the way down to H1. And so it's sort of like a string compression type of problem if you look at it. So like if we go down now, you can see 4 capital P3. So it's saying 4 open squares, white pawn, and then 3 empty squares. And now you see the same thing for the 5th rank in this case as well. So that's how that works. Wherever a piece lands, whenever a piece lands, that portion of the FEN gets updated to represent the current state of the board. Then the second piece of the FEN, so that's everything up until basically here. All right, so then there's a space, and then there's a lowercase, I believe this is where it's W or B, depending on whose turn it currently is. So who it is to move. So in this position, it's black to move, so we have a lowercase b. The third section here represents the castling rights. So in the last stream I talked about, if you're unfamiliar with chess, that first of all, there's a move called castle if you're unfamiliar with that. So let's just play an opening here. This is an Italian opening. And then on this move, white has the option to castle, which is to move your king 2 squares to the right and the rook to come around to the other side. And you do this to protect the king. And you can do this obviously in one move as we've just done here. And it's represented typically in a PGN with the O-O. There's also queenside castling, in which you would move the queen or the king 2 sides to the queen side and move the rook around. That's queenside castling. So that's been incorporated, but the point is that you don't always have the right to castle, or I should say you can lose the right to castle. So if at any point before we castle, we say move the king for some reason, now I can't go back and castle. Likewise, if I move the rook, I can't go back and castle at any point. We also can't castle into check or through check. So if black has some pieces on the board that are, okay, white's just acting insane here, and yeah, obviously none of this is realistic. I'm just trying to point out the fact that now black is actually attacking a piece, or attacking a square, that would move white into check if white were to actually try to castle in this position. So white hasn't lost castling rights here, white just isn't able to castle. So that's the FEN here. If you still have castling rights on kingside or queenside, it's displayed here for white and black. And then what's the next dash in the FEN? So we've got kingside castle. Oh, en passant target, that's right. So this one's a little bit tricky. This is another move that you may not be familiar with if you're not too familiar with chess. But, sorry, I lost the board here. There's a move called en passant. And so the way that en passant works is just to play another really stupid opening. There's an en passant target now you see on f6. And that's because white can actually capture here like this, and that would be taking, in this case, the f-pawn en passant. And so, again, a little bit tricky to code because you have to keep track of time as well in terms of the move. So for instance, if white doesn't take here and black plays any other move, white can't now play en passant still. They have to play it at the time black moves 2 squares with their pawn. The idea is that it's the same as if black had moved 1 square, we can take. If they move 2 squares, we can still take, but we have to take directly after black is moved. So this second to or third to last section in the FEN represents the current en passant target. And that's right, Alvaro. That's a good point. Not only can you not move a king into check from castling, but you also can't move through check. So you can't move on any attacked squares. In other words, I can't move through the f square when I'm castling if black, in this case, has a piece that is attacking the f square somehow. Likewise on the queen side, can't move through the d square when castling if it's attacked by a black piece. So one of the interesting things that kind of came out of that was the use of the sum of all piece bitboard attacks, which have to be intersected with the path that the king moves through when castling. And so if the opposing side's attack bitboards intersect with the castling path on either side, that's actually how we're determining whether or not we can castle. So that's an excellent point, Alvaro. And then what's the last two pieces of the FEN? The half move clock and the full move number. So I actually previously wasn't even representing the half move clock appropriately. So the half move clock is used to make sure that we can correctly represent the state of the game for the 50 move rule. And the 50 move rule is if either side has made at least, or it's once a side has made 50 irreversible moves, non-reversible moves, then they can claim a draw. So it can be a draw if 50 moves have been made that are reversible. So a non-reversible move would be like a king move, or a pawn move. So pawns can't move backwards. And so every time a pawn has been moved, you'll notice that the half move clock actually doesn't increment. But when we move a piece that can move back to its previous square, in other words, it can be used to repeat a position, then we increment that half move clock to 1. You see black comes in and that goes up to 2. 3, but as soon as we move a pawn, that goes back to 0. Likewise, I'm pretty sure if we capture, so let's say that black comes here and we capture, the half move clock also goes back to 0. So we keep track of that. And then the last number in the FEN is just the move number. And in chess, you'll notice that a move is each side moving. So on move 1, white moves and black moves, and then we increment. So a couple of ways that I tracked those things are to start out with half move 2 and a half move clock of 0. And the quote-unquote half move that I have here is just literally half of a full move. And so I'm using that with integer division, so we can just we can divide by 2 to get the full move number. Integer division by 2, so every time it's black's turn, it will effectively increment the half move. So I think that should work. What else do we have here? Right, the half move clock. So we have to be a little bit clever about how that gets reset. All right, so let's clean up some things. A couple of things I'd like to work on tonight are, we can do the 50 move rule. That's a little bit boring, but it is one of the rules. We can do the position has been reached 3 times check. And how about I just take some notes here? We have some to-dos anyway. Use board object for setting attack squares during update. I'm pretty sure that's done. So what can we do here? We can do the 3 move draw rule. 3, it's actually position merge 3 times. Draw allowed. Oh, good question, Alvaro. We can do that too, because no, I'm not at this point. So we can push the FEN to the game stack, which was just an idea that actually just came out of some discussion that Alvaro brought up a few streams ago. And then we could do the 50 move rule. I also need to use existing code dedupe from board class, because this position module is kind of out of control in terms of duplication. There were a few other things that I wanted to do, unit tests, and rightly or wrongly, I'm kind of holding off on unit tests until we have some really solid board representation code nailed down, which is really close, but oh, that's right, we need to do checkmate and king check checking. So we can move the pieces all day long and capture them and everything, but the game goes on forever until we write the checkmate code. So king and check and checkmate code. The type of move legality checking that I've implemented so far is called pseudo-legal move checking. And it's called that because it takes into account all of the legal squares that a piece could move without regards for whether or not it leaves the king in check. And technically that makes a move illegal, because if you think about it, on the next move, if your king's in check in the next move, then the opposing player would take the king, right? So that's the goal of chess, is not to be checkmated. So if a king is in check, you can't really do anything except remove the piece that's checking it. You can block or you can move the king. But the point is, from our point of view, we're going to have to identify the moves that the king can legally move to, which will be the intersection of the king's legal moves as a piece, like one square in any direction, with the complement of the attacked squares by the opposite side. So squares that aren't attacked by the opposite side. Oh yeah, I believe castle would reset it as well. That's a good point, Alvaro. Let's give that a check really quickly. So capture obviously resets it. If we just make a move that doesn't reset it, and then another move that doesn't reset it. Oh, castle actually doesn't reset it, which is interesting. You would think that it would. Castling does not appear to reset the half move clock. I guess technically because it's still reversible in the sense that I could hand castle, whatever they call it, like back into the original squares. It's just kind of funky because it actually involves moving pawns if I have pawns on their starting squares. But yeah, 15 move rules should not be very difficult to implement at this point. It's just not that fun to implement, I think. I think I'd probably have more fun right now trying to implement the actual legality of, or the notion of check and checkmate. So the flow, I guess this is a good point to refresh on the flow of a move on a turn. So we have the make move function method on position. So for better or worse, make move is on our position, in our position module. So what we do is we have a truthy value as to whether or not on passant is set, meaning that we can yeah, I guess it does consider that the king can move back, but it is funny. I would agree with you that I mean I didn't know this either. It just like if I castled in a sort of like super standard position, so I'll just play a Spanish game here, the Roy Lopez, Berlin. So if I castle here, like this isn't really technically reversible at this point because I can't move the king out without moving the rook or the pawns and kind of shifting things around. So it feels like it should reset the clock, but all right, yeah, let's move from pseudo-legal to legal. So we're going to keep the pseudo-legal checks um, up until we've almost said that it's a legal move, and then we'll just check to see if the king is in check after that move and short circuit it there. Because it doesn't matter what piece it is. If I have made a move and this move results in an update that would leave the king in check, then it's an illegal move. So again, for if you're not super familiar, there are things in chess called pins. And so let's try to set up a pin here. All right, so right now, the black knight on c6 is pinned by the bishop on b5. It's pinned because if the knight were to hypothetically move, it would reveal check on black's own king. And so it's technically an illegal move to move the knight. You can see the board doesn't let us move the knight. Because, again, like it's the same idea as to castling into check. If it were our turn next, for a white's turn, we would take the king, which you don't do in chess. You just completely trap the king, but it would be checkmate. So C1, not F1. Oh, I'm always getting that backwards when I'm streaming. I apologize. Yeah, so this knight would have lots of moves otherwise. Like in this position, the knight has lots of moves here. We have 5 different moves. But it's because now if the knight moves, the king is not in check, right? And in fact, it's revealing a discovered attack on the bishop here. So there's some terminology, but right now our program would let us move the knight. And so the idea now is to implement the actual check as to whether or not the king would be in check in that situation. So when we make a move, we do some setting of state for en passant. And then we set is en passant capture to false. Some of this can be refactored a little bit later. But then we say if not is legal move, then we return here and we say, hey, that's an illegal move. I think it's in here that we're going to want to check whether or not the king is, whether or not it's a legal move, leaving the king in check. But it's going to get a little bit complicated because after we say it's a legal move, that's when we actually update the board. So I may need to move some things around here. Rather than return, or let me think about this for a second. No, I'm just going to need to make sure that the removal of pieces doesn't happen before that check happens. So it's got to happen like in here somewhere. Whether or not the move would leave one's own king in check. And if so, it's not a legal move. So part of me wants to actually check this actually in the... You know why this is hard? Because we technically have to update the attack squares on our own... No, on our opponent's side. So let's think about this for a second. So let's imagine that we're black here. And I've made this move with the broken engine, and I've left the king in check. So then I need to sort of revert this and say, oh, that's actually not a legal move, and so I'm not going to actually allow make move to execute. The problem is that typically I'm doing my legality checking first, updating the board, and then updating the attack bitboards after the whole state has been updated. So what I need to do is to actually update the attack bitboards before... I need to update the attack bitboards before I sort of register them permanently, and then allow us to roll back, if you will, if I'm thinking about it. Let's head over to the chess wiki and see what they might have to say about pseudo-legal. So just to demonstrate what I'm talking about here, this is legal move method. Goes down the execution path depending on what piece has been moved, and we do legality checking for the pieces. The pawn one is like a little bit special because pawns can do en passant, as we mentioned earlier, and pawns also promote, and they also capture in directions that they don't move in. So there's a lot of weird legality checking for legal pawn moves. The sliding pieces are pretty straightforward. The king is a little bit trickier because of castling. But basically I go through those types of checks, whether or not they're intersecting with their own pieces. Everything is completely legit there at this point. And then from that point onward, the code currently assumes that the state of the board is going to get updated. So that's the catch. We need to make sure that the state of the board doesn't actually get updated. And so I want to look at... There are so many weird pages in this wiki. All right, pseudo-legal move is legal in the sense that it's consistent with the current board representation. All pseudo-legal generated moves for that position inside to move. For a test of a given but not already generated move, the moving piece on its valid origin square of the board must have a valid target square according to possible move directions and distances. This is so wordy. Although I shouldn't complain, I'm really thankful for it. It's just really wordy. All right. How do I make the... Okay. The occupancy of the target square in conjunction with its piece color, or in case of distance, sliding moves and double pawn pushes, the occupancy of squares between origin and target must be further considered. All that's done to determine if a move is pseudo-legal quiet or capture. So quiet move in this context just means that there hasn't been a capture. That'll actually come into play more when we do search, which is really interesting, because we're not going to want to stop a search on a move that's not quiet, because if there was a recapture after it, then we've stopped the search at like a crucial junction. So we've actually implemented all of this. Pseudo-legal moves may still be illegal if they leave the owned king in check. Most often the king was already in check before, or the moving piece was absolutely pinned. So we just looked at a pin. Pseudo-legal moves versus strictly legal moves is a matter of move generation and also playing hash or even killer moves immediately without explicit move generation. Pseudo-legality test with bitboards. We already did all the obstruction checking. All right, so now I just need to think about implementation, I think. All right. Let's come into here first. Here we need to see if the king is in check. If the king is in check, well, that's interesting. If the king is in check, I was getting ready to say then we have to move the king, but we could also move one of our pieces to block the check. And that would be a legal move as well. Or we could capture one of the pieces that's putting our king into check. So this actually gets kind of tricky. So I think at the end of the previous move, we need to set whether or not the next player's king is in check before it's their turn. That should be the first step. So let's do that. I'm not saying that we don't have other problems, but maybe at the end of make move, before we generate the FEN, I apologize for how procedural all this code is right now. Alvaro says, so either you cross attack maps with the new position of the piece, and if it crosses the position, you ditch the move, or you execute the full move and push it onto the stack, then pop. Exactly. I feel like the latter is going to be way too expensive. Somehow I feel like we're going to be better off updating the attack maps sort of dynamically, like in the process of evaluating the legality of a move, and then just cut the move off rather than allow it to go through with the pseudo legal and then do a subsequent check and then a pop. Plus, from like the perspective of the program logic itself, it just feels a little funky. It feels like a little bit of a band-aid if we had to do it that way. Like, especially if you think like, even though I realize this is sort of beside the point, if you think about like a user interface like this, I can just put my cursor on a piece and see the legal moves. Like, I can click the knight here and I can see that it doesn't have any squares to move to, and that happens instantly. So I don't want to go through and check all these squares and be like, yeah, the knight can move to all these squares. We just ran through that and then somehow have to pop that off of a stack, even if it's not the game stack, which would seem like the worst possible case. But all right, so what I want to do here is to say, either way, we're going to set whether or not the opposing king is in check when the first player makes a move. So if king in check for not the side to move. Which we can check inside of this because it's an instance method. All these ifs. So the first thing that comes to mind is the following. We're going to say evaluate king check. It's too bad that it's called check because it's such a generic word. But we're going to come up here, and I'm going to represent the king check as an array of 2. So white and black, king in check. There can only ever be one king in check at a time, so it should just be king in check. Just makes it kind of weird because we want to set the king in check before it's the end of our turn. So just hear me out on this one. I'm going to start like this. And should never be the case that these two values, I get it that this is like, these are completely disjoint, but it's going to help me reason about it better until we have an implementation. You're right about that, Alvaro. That's true. I am going to generate them either way, so it's almost like it's silly for me to say like it's when we generate them matters so much. But yeah, somehow like getting all the way to the point of saying, all right, now we're going to update the board state, and then, or we're actually going to update the board state, and then we're going to rewind feels like a weird compromise. Like I would love to be able to just include self checks in the like self moves that would reveal self check in the legality checking itself, even though it's going to make what we have a little bit messier temporarily, more complex anyway. All right, so where was I? I'm going to try to have, where did I put this? All right, self.king in check. I realize that this can be represented with a single bit if I can figure out the timing, because there's only ever one king in check at a time. It's just that I want to set this before it's the person's whose king it is move that's in check. And it's going to help me think about it better if I can think explicitly about white and black kings here. So we're going to do it this way for the time being. Self.evaluate king check. All right. Also, thanks for talking about this stuff, Alvaro, because it helps me work out my thoughts. All right, so evaluate king check. So I want to do like the really boneheaded thing here. The first thing that comes to mind here is like, if white king in check, set the value in this array for the white king to 1. If black king in check, set the... I realize that that's like so redundant. All right, so let me just think about this. This is getting checked at the end of the moving player's move. But I would like it to be purely sort of, I don't want to say like functional, but I would love it to not really care about whose move it is. I just want to have this general purpose evaluate king in check method. So that's what I'm going to convince myself of for the time being. So right here we can say if self dot black attacked squares intersects with the self.board.white king bitboard, then white is in check. So this is self.king in check at 0 is equal to 1. We're actually going to else it here as well to turn it off if that's not the case. If self.white attack squares intersects with self.board.black king bitboard, self.king in check at 1 is equal to 1, else this one is also equal to 1, or to 0. I should also add doc strings for all of these, so I started doing that. Oh yeah, that's true. That's true, Alvaro, actually. Okay, so now at the end of a move, that was simple enough because we have the attack bitboards and we have the king position bitboards. What I don't like is that the attack bitboards are a concept on the position module, and the location of the pieces is a concept on the board module. But in a weird way, it kind of makes some sense that the sort of dynamic elements of the game, like what squares are attacked and whatnot, live in the position module. It's just a little bit overcrowded. All right, so at the end of a move, make move function method, we check whether or not the king is in check, and this is just a mutator. It doesn't really, all of this is kind of nasty code right now. I'm a little bit worried about how non-functional a lot of this is. But basically, we're just going to evaluate the king check, and this updates state of king, obviously, king checks. All right, so now it's our move. It's the next person's move. We're heading back up to make move. There's two things that we got to worry about. First is our king in check. If our king is in check, that severely limits the number of legal moves that we have. Then maybe we can worry about the second case, which is in another circumstance where our king isn't in check, but we try to make a move that leaves it in check. All right, so let's start with the first case. Our king is in check. If we have no legal moves and our king is in check, that's the definition of checkmate. So we're getting very close. Like if it's our turn to make move here, and we just start out conceptually with if not self dot any legal moves, And because we also have to program for stalemate, which I can demonstrate in a moment. But if not any legal moves, and self dot king in check, self dot side to move. And then this is checkmate, right? You lost. We don't have an is any legal moves methods, which even like any legal moves and any legal moves implementation must take into account obviously the king being in check. So situation when a king is in check. So let me just think about this for a second. Oh man, getting the moves that would get a king out of check is a harder problem than it seems at first. That implies that we have to gather all of the legal moves in the position and select the ones that leave the updated state of the board such that the king isn't in check. Oh yeah. Ugh, this one's gonna be kind of tough actually. All right, so let's think about this. I might be able to be a little bit clever and move around. We might be able to do this sort of piece rewind in a way that's not like moving the whole position, if you will, the whole FEN onto the stack in the game, do any kind of rewind. I think that's what we're going to have to do because we're going to have to check. We're going to have to check the attacked squares. I could update the pieces moving bitboard if is check is true instead of after, and then the math is way simpler. So it's moving bitboard. Oh, I see. That's pretty smart actually, yeah. There's something also called magic bitboards, like which aren't entirely related, but my understanding of magic bitboards is that it's still bitboard representation, but I think that all of the attack squares are also pre-calculated in the same way that we pre-calculate move squares, for instance, for pawns and the knight and stuff like that. But I know a lot of open source engines use magic bitboards, or at least Stockfish does for sure. Attack bitboard database, which leaves both line attacks of a bishop in one run. Well, when I'm at the point where I have to worry about performance, we can worry about magic bitboards. But right now, I have to worry about performance at all. So I'll throw that out there. But actually, to your point, Alvaro, about working out the that particular simplification during search probably makes a lot of sense. All right, so here's what I think I need to do for the time being. I need to effectively wait to say that this was an illegal move until much later. And when I actually move the pieces, I need to be able to move them, check whether or not that there's any of this illegal state, and then rewind. Which part, Alvaro? How did I do which part? I'm not sure which part you're talking about because there's a delay in the chat. Like here, when I evaluate king check, I need to evaluate whether or not my own king is in check. I want to think of this as a web developer like a SQL transaction. Like I want to be like begin transaction, and then you make the move, you do all your updates, and then at the very end of the procedure, you're like, oh, something blew up, and then you can be like, just don't commit the transaction. Alvaro, if you're talking about the magic bitboards, I don't completely understand them yet either, but that chess programming wiki has some good articles about them. So in my head now, I'm thinking like this. We're making a move. We check if there aren't any legal moves. This is the checkmate check that we'll get to eventually. We do all the stuff that we've programmed up to this point. We update the half move clock. This stuff should be only committed once we are sure that the move is actually purely legal. Yep. So just bear with me. If the way I'm thinking about it is we almost want to be like building a new position. I'm not suggesting that I do this, but like we all right, so I'm not suggesting that we do this, but my thought is like we overwrite all the state on this position with the move once we verified everything. Otherwise, we just throw this thing out. And so replace self.everything in here with next position.everything. So this feels like some JavaScript here, but let's say I do next position equals self, and then I do like this. This is either the worst idea I've ever had or a really easy way to solve this problem. I'm hoping that it's the latter, but I have a feeling that this is really dumb. I wonder if you follow what my idea is here. And in fact, you know how it is when you have an idea and then all of a sudden like you convince yourself that it fits into your design all along. That's the kind of moment I'm having here where I'm thinking like, oh, well, that makes sense. Like make move doesn't feel like it should be part of the position module. It should be this purely functional function that lives out in space and takes a position in and then sends a message to the position module to update itself. So that's my idea. So now make move is starting to feel like it's pushing itself out of the position class. But we're going to go with this for the moment. So next position is equal to self. I wish I could like I wonder if this is like safe to do. I wonder if I should do like a deep copy. All right, but anyway, we're going to do next position dot piecemap, next position dot piecemap. And in fact, here's what I'm going to do. I'm going to do some vim regexing here and come all the way up to here. Actually, the whole thing. And I'm going to replace self with next position. All right, so now we haven't mutated anything on the position instance. But what I want to say is now, if not next position is legal move, or next position king in check. Print illegal move, return. Otherwise, self is equal to next position. Is that even a thing that you can do? This is probably the stupidest idea. Exactly, that's the idea, Alvaro. That's the hope. Isn't there like what's the thinking of a gang of four pattern here. This is the pattern that actually comes to mind. Restore an object to its previous state. And to be honest with you, I've never had a reason to use memento pattern until this very moment. So what can it solve? The internal state of an object should be saved externally so that the object can be restored to this state later. The object's encapsulation must not be violated. Are we violating encapsulation? The problem is that a well-designed object is encapsulated so that its representation is hidden inside an object. All right, well, encapsulation is a bit of an illusion in our case. Make an object itself responsible for saving its internal state. We just kind of did that with assignment so far. Probably not totally correctly. Restoring to a previous state from a memento object. So our memento is next position. Oh no, our memento is self. Yeah, we will have to create multiple paths on the engine. That's right. And I guess, let's say we're doing, I don't know what kind of search. Let's say we're doing breadth first search or something until we hit some path that looks correct. We're going to be pushing a bunch of these position objects onto the computer's actual stack. Anyway, all right, let's see. I feel like I've finally run into a case where I can use memento pattern for something that actually makes sense. Create memento, restore memento. So this is, so I guess the OO way to do it would be to create a completely separate object, and we encapsulate all of the state for this thing like in a store, and somehow like map all of the state back from the memento object to the store that's referenced by the originator. In our case, I'm doing this really weird thing where I am just setting self back equal to the next position. I want to say reassign self Python memento. By the way, Refactoring Guru is a really solid site. And I would also recommend, if anyone's into this kind of stuff, I'm always talking about Sandy Metz, but she's she's got some really good talks on different testing and design patterns stuff. All right, so let's see this. Complexity super high, popularity super low. I'm sure it's the right choice. They're gonna tell us to pickle the instance or something like that and unpickle it, I bet. Or serialize it to JSON or something. The originator holds an important state that may change over time. James, oh nice. Chessable's in your city? Or they have an office in your city? That is fantastic. Chessable's like one of the sort of better things to come along in chess software in a while. So that's cool. If you're starting at part one, you've got a long journey, but I hope that it's fun. All right, so this implementation of the Memento pattern is basically creating this originator object. This would be our position. And the sake of simplicity, the states stored inside a single variable. Do something, generate some strings, save, return concrete memento with all of that state set. All right, this is our rewind button basically. The memento interface provides a way. This ABC in Python is abstract base class. I'm pretty sure we don't need to do that in Python 3. I don't know. Anyway, so these decorators, abstract method, get name, string, pass, method, concrete memento. I kind of want to avoid this complexity because I think I want to rewrite the engine in Rust when we're done. So I'm not going to go all full blown OO on this. Sorry, Alvaro. Alvaro's committed, man. He's always up here when I'm at like 3 a.m. when I'm working on this. It's only about 8 p.m. here. All right. James, since you just joined and you're one of the first, sorry for the train out there. I'll just hold on a second while it's running. James, if you do want to follow along, you can check out the GitHub repo. And there's a notebook in there with some stuff that you can play with to get a sense for where we're at. We're getting really close to being done with a board representation. So we have like the piece motion should be pretty good. We have legality checking in terms of intersecting pieces and captures, en passant, castling, promotions. All of this is actually working. And right now specifically, so let's see. Well, I'm in the middle of breaking some stuff. So on my branch, it's not working, but it should be from the GitHub. Right now, we're working on how do we do checking whether or not a king is in check. All right, so come to this position where I think we can basically use memento, but I don't want to do it this way. Reassign self Python. You live one block from the train station too? Actually, this was like, I have 2 small rooms and this one and another one, and this is supposed to be a bedroom, but the train is like right there, and so it's like hard to sleep, man. All right. This blog article is funny. It's like, am I reading this right? This person just wrote a blog article that was like, this is how this article says to do it. And then he like summarizes how the article said to do it. And then it's like, my opinion is that it would be better if it did this. And I'll do that sometime. It's pretty solid. All right. Why don't I generate the move from the board and then run your legality check? If it works, save it as a move. If not, ditch it. You know, that is another approach. So you mean actually generate the move from the board class and basically only save legal positions? All right, that's going to go in the queue of ideas. But I want to flesh out the memento idea first. All right. So what if I did it like this? Let me just think about this for a second. Can I just have like position factory? It's not even really like a factory. It's only a factory in the sense that like it creates a new instance of a position, but I want to restore it with the state that I saved off. It's just that there's so much state. It's not like that simple example they provided where there's like a state variable. There are all of the bitboards, which is why I want to do something a little bit jankier where I'm just like, okay, next position equals self, and we would just restore self and throw away next position if it's illegal, if it's an illegal position. Let me just think about this for a second. So much state is modified throughout position. Hey, Gregson. All right. I really feel like this is the use case for memento pattern. What has a position right now? Boards have a position? Since boards have a position, Alvaro's point is actually probably a pretty good one. No, right now positions have boards. If boards had a position, which semantically makes some sense, if boards had a position, then we could reassign the new position to the board or throw it out. But right now position is sort of like this singleton thing that, oh, this is gonna be interesting. It's so funny how such a simple rule, like you can program the whole thing. It's so funny how like a simple rule can really be so substantially different from a game perspective. Like capture, en passant, castle, and everything that can all be completely implemented. But then it's like, oh well, there's also this need to check whether or not a king is in check, and that actually has really fundamental implications about the design. One typical person class with some strings and some arrays is way bigger. Yeah, that's true. That's true. The bitboard is literally one 64-bit unsigned int. All right, so let's see what happens when I do this janky version of we can't even call what I'm doing Memento. I mean, at the very least, I could do something like this. I realize that this shouldn't be on the position class itself. In fact, here's what I'm going to do just to like emphasize that. I'm not going to put this into its own object just yet. But let's put this thing up here. Thinking like a real web developer, I could put the position in Redis and then pop it off of the Redis queue and then watch that thing like heat up when I turn the engine on. All right, this is going to be a position. Where is this state managed? This object has to live somewhere, which is why I guess it has to be in an object. What am I doing here? All right, what's it unhappy about? Oh, and then if I could type correctly. Okay, there we go. Oh my gosh. I just screw my head on. And man, yeah, we're gonna have to pull this apart. I have no idea how search is gonna manage all of this. And wouldn't this be like a circular reference with Memento anyway? Hold on, just thinking out loud here. Anak is asking for TDD. Oh man, at this point, I must sadly admit that I have not even written tests for this yet. This kind of started out, I'm surprised that it has gotten to this point, but kind of didn't expect for it, if I'm being completely honest, for a chess engine to really, a simple one even, to be this complex. So that's no excuse for not writing tests, but sorry, I have too many thoughts going on right now. But yeah, I should be running some tests, Anak. It's just I haven't done TDD on this project up until this point. Next position slash self. We're going to go back to self here. And if not, self is legal move. Rewind the bitboards. We would have to reset state on this guy. So either I have a method that basically mutates the entire state, which actually isn't that much. I'm really curious about this rewinding self though. What I'm going to do is just down here. Let's say that I have a class. Doesn't really matter. I realize that we don't need a getBoard method, but like a getter explicitly, but what can I do here? Hold on, self dot memory is just. Let me think about this for a second. Basically, what I want to do is current position is a new instance of position memento. So let's just think about this for a second. All right, so just as a sanity check, and now I call board.foo. All right, Then we say board.x. All right, so now what I want to say is if, whatever, we just want to call the board memento back. So I want to say self is equal to current state. Yeah, that doesn't actually work. So what if we have to do it like this? This is what I was worried about, this circular reference thing. And then have some initializer that populates all the state on board. Let me just work through this logically really quickly. This is what made me think of it being a factory in a way. Yeah, so that's true. It doesn't work, as we just demonstrated. Hmm? That's crazy. Let's check this out. So calling self.dict just gives you all of the members, like all of the adders, I think, on the instance. And then I didn't know about this .update with. Oh, that makes sense. But I didn't realize that the dict object was actually not just representing the object, but was. I see. That's actually pretty interesting. This is like the. This is like some janky code. So this is the thing. Func self. Yeah, same Avro. The interesting, so like if we just call, like let's take one of our things, if we call a small object like this, we get, don't get me wrong, I have no idea really what a mapping proxy is, but I know that when we call ._dict on a Python object, actually what we should do is something like this. And now this is what I'm familiar with, is actually seeing like dictionary representation of the attributes. This is actually a good way to, I think, to kind of get a sense for the highest level of state on a thing in Python. Like what makes up a position? Well, all of this makes up a position, which actually isn't that much, but at least it gives you a high level idea of what state is um, managed on the instance of a position in this case. It's really not that bad. Um, Even if we handcraft this memento to just reset all of these attributes on a new instance of position, I'm pretty comfortable with that, I think. Um, but I agree, this is pretty sort of obfuscated or obtuse kind of code. All right, so let's see what happens when we do this. Name func is not defined. We're actually using PyCharm as well. Self is equal to self dot some other method. So this is like a factory method on the class. Okay. What I really want to do is, feels like it's so much simpler than this sort of stuff that looks like reflection. I just want to be like self.reset old state. Basically, I want to save old state as just self. And self.reset old state, if anything, just returns self. I mean, it's just like reassignment. I'm not sure. Self.reset self old state. Self is equal to old state. Like, this is what I want to do. But it doesn't work like that. What was this guy saying about the... is to call init. But this implies that we set all of our state in the constructor or the initializer or whatever you want to call it in Python. I think the constructor is technically a different built-in. All right, so let's go back to this really quickly. Midnight internet cut out. That's a bummer. So James, right now I'm just kind of down a little bit of a rabbit hole. It's probably not too necessary to go down, but trying to avoid completely uprooting a lot of the logic and the order of things I have when checking the legality of a position. So the crux of the problem is really that I implemented pseudo-legal move checking. So we check everything except whether or not the move would leave the king in check, which would then technically be an illegal move, our own king in check. And if everything is pseudo-legal up until that point, then I actually mutate this object that represents our board state. And that's the thing that represents a position before we switch turns. And since I'm only doing pseudo-legal move checking, in other words, not checking whether or not the king's in check, then we have this problem of needing to sort of roll that state back if the king, our own king, is indeed in check. And one way to reset state on an object is to use the memento pattern. And I think I'd like to give it a shot. But I'm trying to do it in a way that's also like still easily interpretable and isn't a completely bad idea. So board memento self. So board memento instance takes a board. The problem is I can't see a way to reassign self. Like we can do this inside of a method, that's fine. It's just, it's a reference to the instance, but we can't swap out the instance itself. So it looks like we just need to swap out all of the state on the instance, which isn't that much, but it could grow, which makes it feel like a bit of an anti-pattern, at least in its simplest form. But let's take a look. We have a position.dictionary. So I think what we can do is like this. When we want to reset, we take the board memento in and we basically just say self dot board is equal to old state dot board, etc. And in fact, I have a feeling that we can actually just do this now. So I'm going to forget board memento even exists for the time being. And we're going to do it this way. Self.x is equal to old state.x. Self.y is equal to old state.y. I don't know why I made two variables here. Oh, look at that. It's still not the case. The article uses a declaration of the object and then another declaration of the same object as the memento class state-wise and uses init to replace the state. Oh. Yeah, so that would imply that we have you're sending self instead of the elements of the instance, so self.x, self.y. So I wonder if I have to, do I have to pass everything? What am I missing here? Self.reset. old state x, old state y. This is an instance method. It takes x and y. It's resetting. Set self.x equal to x. Old state is just something that is the old self. I see. All right, I'll check that out. Just want to see this really quickly. Oh, like a nested memento class here. I was thinking about doing that as well. Yeah, init mstate self.mstate is equal to mstate set state get state originator reading state rollback. So she has an originator class. State is just a bunch of stuff, whatever. Do something. I'm doing something important. Self.state is generate some random string. Okay, and then save returns a memento. Returns a concrete memento with self.state. So the init method of concrete memento should take in, it should look exactly like the originator. An abstract base class, that's fine. So these methods will get overridden. And then she adds some additional metadata on the memento, presumably to see how old it is before it's caretaker. Oh no, what am I missing here? Caretaker doesn't depend on the concrete memento class, therefore it doesn't have access to the originator state. It works with all mementos via the base memento interface. This is for like a transaction log sort of situation, I think. Originator, caretaker receives an originator, and the caretaker can make a backup by appending mementos with yeah, I mean that is clever. To have this third party basically work at a higher level of abstraction and not work with these mementos directly. You just say, here's a thing that's going to take care of creating that transaction log or whatever you want to call it, and make backups at any point in time, and it's completely abstracted away as to what the caretaker's doing. So from an OO perspective, that's fairly clever. I want a way to set state without mapping every adder myself. That's kind of the thing. In this case, we just have the state being this one variable, and I could do the same thing, and I could wrap it in a state object. I could do like position state. That might make it a little bit more flexible anyway. This hackathon has gone a little bit off the rails, but that's okay. Yeah, no problem. I'm not sure I want to use it either. I do want a way to basically reset state, though. I think that I want a way to do that. It's either that or throughout all of the move checking, it's so hard to do the dynamic attack map updating for every situation, because every single potential move may also say like block an opponent's piece leaving our king into check. All right, I'm gonna stop the thinking for a little bit. I'm going to play one game of chess to clear my mind, and then get back to this something approximating the memento pattern. That's where the dict comes into place. Yeah, that seems to be it. But then it's just kind of like fairly obfuscated code. But yeah, I think that is where it comes into place. But it's also the case that maybe I have too much state to begin with. I don't know. Not really sure what's happening in this position. I think I just blundered. I'm up a pawn, but it doesn't look great. So c takes d6, and then the queen takes on c3. So he's winning the pawn back at the very least. I wonder if I just... So what's my plan? I feel like the bishop's going to be more active on this diagonal. So he gets the pawn back. But now I'm going to just try to finish development. Okay. He wants to castle. I think I want to castle 2. But I want to put my queen on a slightly more active square. So my guess is he should probably play... Oh man, he's playing super aggressively. So I have a feeling that he's going to trade. He seems like a really aggressive player. He's just going to try to trade off pieces and destroy my pawns. I have the bishop pair. I feel like I've got some dark square weaknesses here. My pawn structure is horrible. And I'm finding it hard to want to castle on either side as well. Yeah, this position's rough. I can't castle. I don't really want to castle here. I could try to be... I need to be careful, but now I'm hoping that he's going to castle this side and I can get something going on the queen side. Wow. So I kind of missed that f3 is completely undefended. After he moved his queen around so much, I really feel like I don't want to trade it off right away, but... Almost mouse slip there. So now he probably will castle. He does. So I want to play an endgame. I have a feeling that my position's slightly worse because of the pawns, but if I play rook b1, what does he want to play? Does he just want to play d5 and just start hacking? Yeah, this is a mess, James. If you end up working at Chessable, don't tell anyone about this or any other of my games. I'm just kidding. All right. This is horrible. What about castle? Sorry. And now we have a pin problem here. Yeah, it's definitely too late to castle. I sort of stupidly went for the bishop pair, I think, in this position. But my hope now is to win the A pawn. Unless I'm probably still missing something. But he's up a pawn, and yeah, at the very least, I guess, can I win my pawn back like this? And now at least his knight's pinned. A7, that is where we go. Yes, yes it is. All right, so I feel like I have another tactic here. Um, right now I'm thinking bishop e6. I think bishop e6 wins more material. No, because he's got king b8, but then I've got rook a1. Oh, I'm an idiot like that, but I think I can still win more material here. I missed this, but I also missed that I would be attacking here, and I'm running low on time. But I think we're doing just fine now. I'm just gonna try to play it safe for a couple of moves, and move my king to the center of the board. Okay, let's see what we can do here. Running low on time and playing on the trackpad. Trackpad is not what you want. Yeah, there's a delay on the chat. Sorry about that. And I just blundered. Um, I just blundered. Oh well. I can force the rooks off now, I think. And with 9 seconds left, I probably am going to get flagged, but what can you do? So this will be a draw. If I don't completely screw it up, it'll be a draw. Actually, I'm winning, but it's a shame that I don't have any time. All right, that was a good refresher. Back to this memento nonsense. So the crux of the problem is we need to restore state on the position in the case that we actually have an illegal move, due to the fact that the king's in check. All right, so what I was kind of missing in here was, why is this not the case? Probably should have done this in C# to begin with, or Rust to begin with. All right, so that works. So what if we called I think it's star data. So how does this one work? Reset takes one position argument, but two are given. All right, so board state is just a thing. That comes in as a tuple of probably, what's that, named arguments? And this comes in as, I think the tuple is probably just because that's like ordered arguments, args, and then this is quargs, keyword arguments. So why doesn't this take anything? So it takes one position argument, but two are given. Yeah, splat operator. Oh, that's interesting, Aura. Yeah. We no longer need a stack of moves, but a stack of mementos of moves. Yeah, I'm really interested to see how this search is going to look. That's really funny. That's an interesting idea. I hadn't thought of that either. So here, this would be like if board took in some board states. I would love not to have a constructor that takes all of this state, just have like a board state. And then only if needed, then use board state to update these if needed. where this had like a reset state. This then took board state. I see what I was doing wrong here anyway. Then this took board state, and then what I did would be like board state.x self.x is equal to board state.x, self.y is equal to board state.y. Now the idea is I only need to worry about constructing a board with board state. I think I'm pretty burnt out after a week of work, but self.reset. Then I did something like this. So we make a board, call board.foo, board state's not defined. Just made it here. Local variable board state used before assignments. Board state is not defined. Oh, what am I doing? Hold on. Man, I'm running out of energy here. Index is not defined, and this is not JavaScript, so reset. Dictionary has no attribute X. Okay, so something like this would work. And then the only thing that gets the nasty initializer is the state object DTO thing. And technically it doesn't need to know anything about the board itself either. Can I do like args, quargs, or something like that? Then we need to basically get all of this state, which actually isn't that much. So a couple things I'm going to do here. Pretty sure that's how that works. It comes in as a tuple on quarks. That's kind of not what I wanted. Yeah, I see that it works the other way around. I wish this came in as not a tuple, but as... What I wanted to be able to do was something like this. So I guess I have to pass them in order and then use it like a tuple. Wanted to do this. Oh, that works too. Really? Yeah, okay. The other demo was showing that came in as a tuple. I have a feeling that's what this is, the args. All right, so this is going to work more or less like we want, I think. All right, so self.borg is quarks.board, self.color to move. When I think about it, I'm like, man, this is kind of like feels weird that I have to rewind to this state, but it's like explicitly what I feel like we need to do at the moment. I mean, I'm sure that there's a much more efficient way to do this. But all part of the learning process. And actually I can move position state out into its own module as well. Actually only a few more pieces of state on this. We've got king and check, which was just added. And we've got piece map. Now I'm not going to type all this out, so I'm just going to do self dot for all of this. And then I'm going to try to be clever here as well. Actually, that's not really going to work well, is it? All right, so then let's clean this up a little bit, and I don't even know what these cars are. I'm feeling that it's a Mac copy issue. Sorry for all the tedious work here. And then can't I to the end of every line? How would I do that? $, then I can do space equals quargs chungba. All right, getting closer. So maybe I'll do that. And then do this. All right, thank goodness for regular expressions. Except that I'm not clever enough to slice out the self dots and put them in place here. Could probably figure it out, but can you simply replace the above with, or caret with self, and then with quarks, and then simply add, yeah. I actually only ended up saving myself a little bit of typing. There's a way with Vim regular expressions, actually with any regular expressions, to get like a capture, well in Vim to get a capture group from the selected text, which I think is just an index. I think it's like 0, 1, something like that. Black pollen attacks. But I always forget it, and also I'd have to slice up to self and black knight attacks, black bishop attacks. Yeah, that's true. I should record and use a macro, but I did not. All right. There's our position state. Then when we want to reset from state, we have a reset function on board. When she made her example, this what actually did the reset? Was it the caretaker? No, it can't be, right? It has to be the originator. The originator has a restore on itself, and it just sets its state. So that's exactly what we're doing, except I don't have this third higher level of abstraction in the caretaker. That's like this transaction log keeper. Yeah, then spiral 1. Oh man, your Vim skills are probably way stronger. Also, I think at the beginning of this series I was writing in Vim from the start, and then I switched over to PyCharm. So, I'll probably move back to Vim when we start doing unit testing, because I do have some key bindings set up in my. There's a nice plugin if you're doing either JavaScript or Python in Vim that I use called. You could also really easily just remap your own keys for this, but this Vim test by Janko M is pretty nice. What it does allow me to do is, for my Python, I remap my leader keys to, and this is provided by that test plugin, and so we can test like the method under the cursor, test the method, all of the test methods in the file, or run all of the tests. And so that's test nearest, test file, or test suite. And then you just specify, I'm pretty sure, like what test runner you want to use. And so you could do like test whatever runner here. And since I use PyTest, it just basically remaps these leader keys to, again, run PyTest for whatever context we're in. So I did not write my own macro for that whatsoever, or my own Vim plugin for that, I mean, but it's a good one. Vim test by Janko M. And also Tim Pope's plugins, which I'm pretty sure almost everyone who uses Vim messes with some Tim Pope plugins. All right, so we got this state. We have to have a way to restore a position from a memento. What's really cool about this, though, is this position state memento is just a DTO. Yeah, I think it should be in my .files, Alvaro. I believe so. Alvaro, to your point about potential other use cases for this pattern and how maybe like we don't have a stack of moves, but we have a stack of mementos of moves. I'm just thinking about the fact that whether or not that's the case or not, what's kind of cool about this is that this state DTO represents a snapshot of any position. And a position object with a reset method on it can turn itself into any position, and this object can live completely independently. Like we could make up a position state, we could tie the FEN input to just generate a position state instance and then feed that to the reset of the position instance and basically reset any position from a FEN input. Likewise, we could replay entire games as stacks of mementos, kind of like you mentioned. And we don't have stacks of positions anymore. We just have the state represented needing to create positions. I'm trying to think. It seems interesting. All right, so now we need to come down here, and I'm just going to put it up here where, let's put it under initial piece condition, locations. We're going to say reset state from position. And here we get a memento, which is of type position state. And it doesn't return anything, it just mutates. And then here, what we say is like, I feel like there must be some clever way to use like the Python dictionary instance here, like for adder in memento dot get attributes dot all attributes dot dictionary dot keys. Then what we could do is like, actually what we could do is this for key value in memento dictionary dot items. Then I think we could do self, well, we need to do like self dot dictionary dot whatever. We need to do self dot get adder, right? Isn't that a thing? Oh man, what's the Python get adder? I'm trying to come up with a way to do this without like mapping everything manually. Does it mean that you need to attach the FEN representation to the memento? So like make a morph approach between position and position memento, right? I think good question. There's probably a couple ways we could do it. What's coming to mind off the top of my head, and I'm super tired, but what's coming off the mind on my head is trace commas. It is numpy, and it uses that uint64 as it uses an underlying C type that's actually 64 bits, as opposed to the native Python uint64. So this is not what I was looking for. If you look up numpy scalars. So Alvaro, off the top of my head, one of the things that I was thinking of is, because it's a good question that you raise, uint, and under the hood it's using a 64-bit C. What's the actual name of this C? Primitive. I can't find the, I can't find the, there's a document as well describing exactly what C types the NumPy translates to under the hood. But Alvaro, what I'm thinking is I wonder if position state is given a little bit more intelligence with regards to FENs. And so maybe position state has a method on it like from FEN and has like one FEN parser on it or something like that. Like we have an object that's an FEN parser, which we extract from the position class right now. Like we have self.fen parser. Or we inject it or whatever, but we have this FEN parser and then we have def from FEN string, and then we can say self dot update state, which would update all of these after parsing the FEN. So it might be like self dot FEN parser dot parse string. Here's our FEN. I'm just winging it right now, but and then self.board is equal to this, and everything gets populated from that. There is one sort of nasty thing about all of this, which is that this board instance is kind of a big thing. And actually the board instance isn't that bad because from a logical perspective, it's not that bad because it is like the static bitboards and things like that. But I'm more concerned that I don't really want a board instance, that whole object floating around with this DTO. Like I almost want the position to always be able to create a board in the way that I've laid it out, given like, you know, but anyway, yeah. I don't know. It's a really good question that you bring up, Alvaro. As usual, actually. All right. So we were at this reset state, and I was gonna do this get attribute. All right, Memento was fun to play around with. We are actually using it, which is kind of fun in a way. All right, here's the slow way to do it. It's going to be self.all of these attributes get set. So let's see how that would be implemented. Coming all the way back to make move. So we create a position memento, which is actually now just not a position memento, but it's a position state. And get rid of position memento. It's the same idea. And I think part of the lapse in my logic previously with a memento was the memento is retrieving state. It's the instance of the originator that has a method on it to return its own state from a memento. So that was part of my confusion. So current position is some position state object that takes self and Yeah, here we can take self.dictionary as my hope. And it's saying that unexpected args. Oh, it's actually expecting the whole thing. I mean, what I could do is I could say, call this thing quarks just for the time being. Come on, update. Okay. Come back down here and we can pass it like this. I'm kind of getting all over the place with this extra Python-y stuff that's kind of not, I don't always use, but all right, so current position is equal to position state, self-dictionary. So we have this position state memento object. And the idea is that we want to rewind the bitboards, so to speak. We want to say self.restate from position memento. I'm going to not call it memento because I feel like someone coming in and reading the code might be like, why did you call it that? Call it original position. All right, so if an approach at least along these lines works, then it really means that I don't have to completely rewrite make move yet. May have to rewrite it when we get to other parts of the program, but as far as board representation is concerned, if this works, I'll be happy with it for now. I kind of want us to get to the point where we're doing search relatively soon, like actually looking for moves. So maybe I'll wrap this up off stream and maybe in the next stream when I do stream, we'll actually be doing more search and position analysis. So let's look at chessprogramming.org really quickly. All right, when they talk about getting started, which is where this all started a couple of weeks ago, I have like a love-hate relationship with chessprogramming.org so far. It's like it's a completely invaluable resource. It's really fantastic that this exists, and it's just really hard to navigate in a structured way, I would say. All right, so board representation, we're getting super close to finishing that. To make it bug-free is quite a stretch. I have a feeling it's pretty bug-free, but I'll feel more confident when I write some unit tests. And I would like to have 100% coverage on this project. I don't think that's unreasonable. It's pretty small at this point. Castling is done. Repetition draws isn't done, but that's going to be pretty easy given all of the functionality that we have. Once you have a nice solid foundation, you're ready to start learning about search and evaluation. Some interesting sounds happening outside the window. All right, so Claude Shannon, one of the more interesting figures in the history of computer science and the father of information science. A chess player and also programmed one of the first, I believe perhaps the first chess computer program. So there's Claude Shannon. That's Lasker. Not Emmanuel Lasker, who's an even more famous chess player. Emmanuel Lasker is the Lasker I was thinking of, who's like way more famous. This was, one of the early world chess champions. Yeah, if it can be called organization, I agree. I it's like so much great information organized in such a haphazardly way, but I mean, I guess these people are putting in the effort to come together and supply all this information. So I'm super grateful for it. All right, so search is something that I actually have professional experience in, so I'm hoping that it will help expand my understanding of search to another domain. Um, so I just want to get a quick idea of where we're headed because the next stream will be focused on search. So most chess algorithms use variation of alpha beta to search the tree in a depth first manner. Yeah, I've heard of Negamax. I'm gonna look at this one. Minimax and derived algorithms using two separate subroutines. There's one other thing that this reminds me of as well. I want the program to be UCI compliant. So that I can run it with like standard chess GUIs when it's completed. One of the things that caught my eye in the protocol, though, is that the engine should take input even while it's thinking. So the problem with that is that I haven't thought about that yet. So we'll have to think about that. Python's got the global interpreter lock, and so we're going to be bound to a single core, a single processor. So that's clearly not ideal. There are definitely ways that we could use multiprocessing to get all that to work. But I almost wonder if it's not worth the effort to write this in a slightly lower level, rewrite this in a slightly lower level language once I start to feel relatively comfortable with the basic implementation. I don't want to solve like a whole bunch of really hard problems and then rewrite everything anyway. I would like to get a very basic chess engine working in Python, and then I think once I have board representation and a basic idea of how Minimax works set up, and position evaluation. Position evaluation is going to be really fun. Once I have that set up, I think I want to move this over to Rust or perhaps C Sharp. But I'm kind of leaning towards Rust. So they go for tree representation, so connected nodes, I guess, and recursive navigation given the infinite number of paths, hence the deep level, right? Yeah, I suppose so. Although I'm a little bit surprised that it is a depth first search. Because if you think about it, I mean, it'll be interesting to review my thoughts once I gain a better understanding of the actual theory and the implementation here. But my initial reaction is, why not a breadth first search? Because we have relatively few number of possible moves per position relative to the extreme number of moves, like a few plies deep. So, but it's interesting. So there's a maxi and a mini. I'll be honest with you, I've heard of minimax a lot, but I don't know what it is. I don't know how it's implemented. To determine the score in a zero-sum game after a certain number of moves, the best play. Evaluation is going to be the fun part because I think we're going to get to sort of play with the different parameters. And it'd be fun to use the bitboards in this evaluation phase where we look at whether or not we want to take into consideration certain like chess heuristics like control of center squares, or try to create some quantitative metric for like for ideas in chess, like initiative. Try to evaluate things like open or closed position and the relative value of knights or bishops in those situations. So I think evaluation is going to be a lot of fun. Search is going to be a grind. All right, in a one-ply search where only move sequences with length 1 are examined, the side to move max player can simply look at the evaluation after playing all possible moves. Okay, that's what I was in my head thinking is like first level of a breadth first search is every possible move from current position. The move with the best evaluation is chosen, but for a two-ply search, when the opponent also moves, things become more complicated. The opponent min player also chooses the move that gets the best score. Therefore, the score of each move is now the score of the worst that the opponent can do. Each move is now the score of the worst that the opponent can do. I see. So if I make a move and then you make the worst possible move after that move, someone else makes the worst possible move. Okay. John von Neumann, another super interesting character. There's this book, The Prisoner's Dilemma. Pretty sure that's what it's called, or maybe it's just called The Dilemma. Von Neumann. Yeah, there's this book that's pretty cool. Kind of a, man, I feel like the 20th century has so dark, but as it was, but another interesting character. All right, so let's just think about this for a second. So if this is depth first search, all right, in depth, depth equals 0, return evaluate. So if we're not going through any search at all, we're just going to return the evaluation of the current position. That makes sense. Int max is equal to negative infinity. I suppose that's what this is representing here. For all moves, score is equal to the minimum score at depth minus 1 if the score is greater than the max score. Max is equal to score. Int mini depth return negative evaluation. Int min is plus infinity for all moves. Score max is equal to score is equal to maximum depth minus 1. If score is less than min, min is equal to score return min. Negamax is used for simplicity. This means that the evaluation of position is equivalent to the negation of the evaluation from the opponent's viewpoint. This is because of the zero-sum property of chess. One side wins if the other side loses. That makes some sense as well. If you look at the way that chess engines evaluate positions, like typically, if again we go back to Lichess, the way that they're evaluated is the more negative, then the more black is winning, and the more and I did not mean to start a 1 minute game, but we'll play a quick game of bullet, I guess. And the more positive, then then white is winning. All right, so really non-standard opening here. And it's bullet, and I'm playing with the trackpad, which is like the worst idea. Okay, he was not expecting me to play that move because the move is pretty bad. But here I have a nice fork. Yeah, I'm still gonna take it. And then what do I have here? I'm just gonna cut off that diagonal. And now swoop in here. And what do I have? Rerouting. All right, I'm gonna get rid of this bishop. That's no good. He just won my queen. I missed that. And now I'm getting completely crushed. It was looking good for a little bit, but it was too good to be true. Try to trick him, but he's too quick. All right. The whole point of that was that instead to try to go to analysis board. And what you're going to see is a huge negative score here. So if we turn on Stockfish, which is a really strong chess engine, you'll see that the score is -9 point something. So it's basically 9.5 pawns worth of material. So games typically start out with a very, very slight advantage for white because white gets to move first. And then as the game progresses, the evaluation changes. And in fact, if we run a computer analysis with a legit engine like Stockfish, one of the things that we can get out of this is a nice graph in this particular GUI. And so you can see like the course of the game, the evaluation. So I clearly just blew the game, but the point that I'm trying to make here is that all of the times where white has an advantage, you have a positive float, if you will, and then whenever black has an advantage, you have a negative float. And so Negamax is saying that the evaluation of position is equivalent to the negation of the evaluation from the opponent's viewpoint. So we get this idea of just a plus or minus score for any given position, and black considers his position or her position better with a negative score. There's some other cool metrics that we get here, like average cent upon loss per move, mistakes and inaccuracies, the FEN and PGN. So this generated a PGN, which would be another thing that we'll have to generate with our engine, which is like just a record of the game. So we have some metadata up here. And move times, which is another interesting metric. Move times and things like that are tied to could be tied to the GUI as well. I don't know if that needs to be part of the engine, but it could be. In fact, some notion of time may be necessary in the engine for the purposes of setting like how long we're going to think per move if we want to test the engine, that type of thing. But not sure yet. So UCI protocols on the back burner as well, noting that we're going to need to be able to take input while the engine is running, and so that either means multi-processing or multi-threading with Python, which has its own problems because of the global interpreter lock. Kind of all over the place right now, but we'll get to search in the next stream. I've been out of time now for a little while, so I'm going to end with one game of GeoGuessr, and then call it. If it's not just what path leads you to the best position, but also the path where the best options for the opponent are the less worse, then depth 1 is a move of 2 players. Yeah, I think depth 1 is... I think 2 ply is the depth of 2 players. I'm not exactly sure. A two-ply search, when the opponent also moves, things become more complicated. So one ply is just your move. But your move takes into account the... But I see what you're saying, because if depth 1 takes into account the possible moves of the second player to move, then the second player to moves have to be evaluated, right? Good question. Looking forward to diving in deeper on that implementation. I have a feeling that's going to be kind of a grind, but... Alright, we'll play Diverse Worlds. Play 1 or 2 rounds. I've been doing 1 minute and 30 seconds, but I'm going to do 2 minutes this time to compensate for some of the lag when I'm streaming. Alright, yeah, I'll just play 1 round. I don't know if I'm feeling GeoGuessr this evening. So this looks pretty tropical. Kind of thinking maybe Central America. There's some beautiful mountains in the background. So we're headed south on this road, it looks like. So I don't know, my first thought here is like Colombia. Of course, it's a little bit hard to tell. Be nice to see some more signs. I also need to get myself a proper mouse. Puesto militar de Las Tunas. 14 kilometers. Las Tunas. Hervidero. I don't know if I'm saying any of that right at all. We're gonna try, I don't know. My first thought was Central America, but I kind of feel like, then I thought maybe Colombia, Ecuador. It's not much for me to go on here, I guess. Also, I realized like that my picture is like over the chessboard half the time, so I apologize for that. Further north, we're actually in Mexico. Also, my cat is trying to get in, so I might try to let the cat in here in a moment. Scratching at the door. Alright, where are we at? A400M. This one's kind of hard to tell as well. Again, we have some nice mountains in the background. Looks a little bit more arid than the last one. If we are in... This could, of course, still be Mexico by the looks of it. Let's see what's on this billboard. Cuba could be. Municipalidad de San Nicolas. I don't recognize this flag if it is. I also don't know what the where the municipality of San Nicolas is. Have I planned already for my next stream? I haven't planned the date, but it won't be this weekend because I've got to work on a course this weekend, but I anticipate that it'll probably be like probably next Tuesday, something like that. I could try to do one in the morning sometime, although I have work, so it would have to be on the weekend sometime. The next several streams on this should be really interesting, I hope, so because I'm really hoping to finish most of this sort of these ideas off stream, and then we can work on search soon. About ready to run out of time. The best guess I had here was Mexico again. But some of it looked almost like Peru even. Chile. Wow, I should have been way closer with Peru. That was horrible. I don't think Mexico calls its regions municipalities, by the way. I know Brazil does. That's Portuguese, so I don't know. All right, so where are we at now? Also, Alvaro, thanks again for all of the talking back and forth about these ideas. It's helping me a lot figure out how we're going to implement this thing. All right, so that's in Cyrillic, obviously, but I don't know where, except to say that we're probably in Eastern Europe somewhere. So my guess is that we're in Ukraine. First guess is Ukraine. Just gonna put it over in Ukraine until we know any better. Pretty flat as well. Be great to get a read on the road that we're on. So this is a pretty wide open road. All right, finally we get a road sign with 16 seconds left, and then I blew right past it because I'm speeding on this road. All right, so let's get back over here. Please just say like Kiev or something. I can't see it. We were in Ukraine, but we were like 300 miles away. All right, next round. All right. Bielefeld, Europe somewhere maybe? Agropecuaria. Is that Portuguese? Are we in Brazil? Or Portugal obviously, but I don't think we're in Portugal. All right, so current guess is Brazil, but that's not really narrowing it down much for us, is it? Is the guy just going for a run with his dog? All right, 1 minute left. Second to last rounds. What Brazilian municipality are we in now? Maybe Mato Grosso, or that's the only one I know off the top of my head. Also, it's still kind of a long shot that we're in Brazil, but since I said Mato Grosso, we'll put it somewhere there. And we'll keep searching for other clues. Also, I don't even know if what I saw earlier was Portuguese. Tres Tentos. Yeah, so we're not in Brazil actually. I'm pretty sure. Oh, we are in Brazil. We weren't in Mato Grosso. We were in Rio Grande do Sul. Rio Grande do Sul. All right, last rounds. Monterrey. So we're in Mexico, obviously, because the sign says we're in Mexico, and we're on Route 53. So let's see how close we can get with this incredibly useful information. So we are basically south of Monclova and north of Monterey. How far? Maybe we can find that out too. We turn around and look at this sign, and if the lag doesn't kill us. The lag is killing me. All right, we're on 53. Monterey is that way. There's no sign of how far, but let's find Monterey, which is here. And we are north of Monterey. And we're in between Monterey and what was the other one? So I'm going to put us on, if I can even find 53. Is this the reset? Yeah, return to start. That's what we want. Monterey's that way. Monclova's in the opposite direction. So we're north of Monterey. Monclova's in the other direction. Oh, there's 53. All right. How close can we get with 10 seconds left? We're at a crossroad. If we are at a crossroad, it's probably that one. No, that's not even a road. That's just the... All right, well, we're close. Super close. 30 miles. That wasn't too bad, but we got super lucky with the sign. Okay. All right. I got a few minutes left. I'm going to make a commit with some of the stuff that we got here. All right, I'm just going to go heads down here for a couple of minutes and do this. This is where I wish I had C# and AutoMapper so we could just map this back into place. I also really feel like there is like... I really feel like there's something like this in oh, nice. You're on holiday now. That's fantastic. Oh, and you don't have to worry about being too noisy in the chat at all. It's like it's awesome to be able to hash out ideas with you, so it's no problem. All right, so for what I really want to do is this. I think there's a way to Setattr Python. So I bet I can do like this. Setattr self key value. Please tell me it's as simple as that. Unless there's some kind of weird other metadata on this. If it's as simple as that, I'm super happy with that as an initial cheap implementation. Let's just see if that works here. Reset from board state for key value in board state dot dictionary dot items Setattr self key value. It's too good to be true. Dictionary has no attribute dictionary. Key value in board state. Oh, wait. Oh, by the way, I need to pull this. Again, push. Yeah, Alvaro, I'll set the live stream messaging up early, like a few days in advance. That way, at least you have a heads up if you're interested. But yeah, sometime next week for sure. Uh, and also, glad to hear you're on holiday. That's fantastic. I'm on. I think I get off a few days next week as well. All right. Is that Visual Studio? Ashwin asks. This is at the moment. This is PyCharm, which is a JetBrains IDE for Python. By the way, what am I looking at here? Why am I up in this Setattr thing still? Oh, it's because board state is dictionary. Ceph is not defined. You don't say. Nice. So I think this actually works, right? So we put some other junk in here. Sweet. So this reset is like a lot cleaner than I thought it was going to have to be. Memento is an object though, so the way I did it was to say, all right, so foo comes in here, board state is this, new state is this, self.reset board state for key value and board state dot items. Why is board state a dictionary though? That's what I don't understand. Oh, because I splat it. I could do it like this. And it takes one argument, but two are given. Oh, because I did all of it this way, actually. Yeah, all right, so I'm going to go back to do all of this way. And just a spot check here. So that does not work like I expect it to. Oh, yeah, it does. Okay. All right. Yeah, for sure, Alvaro. I'll put a heads up on the channel. I don't know how YouTube is about like sending notifications, but if you just check back in on the channel, there'll be a note. That'll be the next thing I do. I don't have a new video coming out before the next live stream. Yeah, this is Ashwin. This is a backend for a chess engine. It is the chess engine. And I'm not using Pygame or anything. This is just Python and NumPy for everything. And the idea is that I'm ultimately going to be building a UCI compatible chess engine so we can plug it into like a standard chess GUI program like ChessBase or Tarash. There's a few other ones. And I'll probably end up rewriting it in Rust before I set it down, if I can ever set it down. Let's see here. So this reset position, reset. If this comes in as a dictionary though, should be able to call items on it. Reset position gets called from here. How did I wire this up before? Reset board states. Original position comes in as a position state. And here I did something like this, actually. All right, I'm going to mess with this part off stream. Make sure that I have an implementation of this memento-ish thing minus the caretaker class or whatever that is that slightly higher level of abstraction. Just basically a way to rewind state back to this before it's committed. I still like the analogy of the SQL transaction here. Basically make sure that when we run this huge update and delete statement or set of commands that that if we get an error anywhere that we roll back, or not that we roll back, but that we simply don't commit the transaction to the transaction logs. And we can think of a stack of mementos as our transaction logs, which is actually explicitly what a caretaker is in that refactoring guru example. It's a stack of, well, it's a list of. Yeah, I'm not super familiar with the protocol either. If you ever look up like some legit chess engines that are feature complete, you'll see them mention that they're UCI compatible. And one of the cool things, like if you check out this site, chessbomb arena, I can't remember what it is. There's like, I think like one guy who runs this site, but every so often there are these computer chess championships, which, to be completely honest with you, I don't follow. Computer chess games are several thousand ELO points above my level of understanding, but they basically play chess engines against each other and see who wins this TCEC championship. And I'd say like my dream, like if I could work on this off and on for like the next year, would be able to compete competitively. That's like a super long shot. But the chess engine rankings would be cool to get in like the top 100 or something. There are a lot of chess engines out there. I keep seeing this Shash chess, which I have not heard of that until recently, but Stockfish is really like the top consumer chess engine. Alpha Zero is the top chess engine, but it's not like available to consumers. That's right. Yeah. Well, it'll be a legit engine when it can actually evaluate positions. Do search. And I mean, if you look at the source code for some of these engines, like for the most part, they're all written in C, and are extremely tuned for performance, so they can evaluate position like at really serious depth. And but anyway, the goal is to get on the CCRL list. I would love to be like on the list or have Wake on the list, since it has been kind of a fun project. But I feel like I'm still maybe like a good year off from that. We'll see how things go. But yeah, that's it. It should be fun to rewrite it in Rust too. And I think it'll be fun to compare performance between prototype, which we're currently building, and slightly more polished version. Some Kraftwerk, some classic krautrock there. It's interesting. This wiki has like all these like jazz musicians and electronic musician like YouTube things at the bottom of every article. Anyway, all right. Thank you all for joining. Alvaro, thanks for the chat. Why awake? I never said it. It's because I joked with my friend about this when he asked me the other day. It's like really close to weak, but it's not weak. It's not because it's close to weak. I came up with the name like a super long time ago, like a few years ago. I was gonna build a GUI called Daydream, and I was gonna build a chess engine called Wake. Not any particular reason. I didn't think about it too hard. So I don't really know why exactly. Um, my handle in a lot of places is, in some places, is River Run, which is the first line of a book called Finnegan's Wake. The first word is in a very strange book called Finnegan's Wake by James Joyce. And this book is really fascinating. Like, um, it's it's kind of like a cycle, like, but it's a really abstract book, and I don't really completely understand it. But basically, it starts with. So, long story short, it's in part inspired by this book as well. But I wanted to show something here. Little known fact about where the River Run name in my Tmux pane comes from. So if you look at this book, whoa, did Gutenberg get an update on the way that they're? Yeah, okay, full text to Finnegan's Wake. I just want to get to the full text so I can end this rant that I'm on here. All right, here we go. So River Run past Adam and Eve. So W's for West. I should have just said that because I don't have a good reason as to why it's called Wake. So um, there's where River Run comes from. And then if you go to the very end of the book, um, well, if you do go to the very end of the book, you'll find that the sentence kind of like loops around back to the very first sentence in the book. And I can't navigate this website either, but it's a cycle, and the book just goes on, in this loop, which is kind of interesting to me. Let's see if we can go to the very end. Man, websites are so bad. Websites are so bad.